Hey everyone. A few videos ago I had talked about my heating system, which is a oil burner with a forced hot air furnace. This video I wanted to talk about electric baseboard heat and a situation that a relative's house ran into with their system and a malfunction. So as I'm sure a lot of you are familiar with, the thermostat is what you use to control the demand for heat. When the set temperature is above the actual temperature that it detects, it will call for heat and turn on the system, and when that is achieved, it will turn off. In the case of this relative's house, their room temperature was reading like 75, the demand was 70, and the heating system was still on. The radiators were still pumping out heat. So they called me in a panic. They're like, what do I do? I had seen this once before. Let's dig into it and I'll show you what happened. There's two different types. This one is a low voltage one, and what this does is it runs off of typically like 24 volts AC, and there's a set of contacts in here that will close when it calls for heat. So when the temperature is set higher, hear that click? That's the switch either calling for or stopping the call for heat, and that's making a connection across that 24 volts, which then goes back to the relay at the breaker panel, and that's what is going to turn on the high power. So you don't actually have high voltage, high current running into this area. It's typically a very thin wire. These actually, in the old days, there's a bulb with mercury in it, and when the call for heat took place, it would rotate and the mercury ball would move and make contact, and that's what actually closed the circuit. Obviously, mercury is not a good thing. It's toxic and all kinds of stuff, so a lot of these have gone just to either a bimetallic strip or a spring-loaded strip of some kind that makes contact. On the other end of the thermostat, these wires here, which go into this relay, this actually has a transformer and a heating element, so when the call for heat is made, that heating element turns on and causes a set of bimetallic strips to bend, making contact and closing the relay, turning on the high voltage and high current to the baseboard heating. This guy got stuck on. The contacts fused and caused the heat to stay on even after the thermostat was done. So a quick little got the contacts to free up and make the heat turn off. But obviously that's a sign that this guy is compromised. Time to replace him. So this is a high voltage thermostat. So same as the other one. However, this one, like a light switch, has the high voltage, high current lines coming into the box. Basically like a light switch, but it's controlled by the temperature. So when you set this here, and it clicks, that's closing the contacts and putting power out to the heat system. In this case, this house has electric baseboard heat, so this is going right to those loads and turning on the radiators. Turn it off, and it is instant off. So unlike the low voltage, which has that delayed response, this one is instant. So it's important for these to actually have a little bit of hysteresis in them, so that the turn on temperature and turn off temperature are not exact. Otherwise, the contact could chatter, and you don't want that to happen. So that's what the high voltage thermostats do. Let's perform an autopsy of the failed relay so we can see how it works internally. I'll start by cutting these snap-on fasteners and removing the outer cover. So here's a transformer. Get this insulating paper out of the way. You'll find that in a lot of these any of these high voltage applications that you'll have insulators. I believe this is the one that, judging by these by the heat marks here, this is what actually gets hot, and it causes this to bend, and that will then push down on this switch contact right here. The mechanism employed here is a bimetallic strip, which is two dissimilar metals bonded together. When heated or cooled, they change length at different rates.
This results in the strip bending, therefore giving this mechanism the ability to depress or release the main power switch after a short delay once the call for heat is made or stopped. Yep, there you go. 90 ohm, 5%. It's just a power resistor. So you got the transformer here putting out 24 volts across 90 ohms. That is going to heat this up, which causes it to change shape, which would then cause this to push down and then push this switch. So our mode of failure in here was probably in this switch, in that the contact's welded. So let's see if we can open this up. That's 22 amps. See here. Yeah, there is. I mean, look at this here. That's nasty. I don't know if there was something they put in here to preserve it, but I don't know. That just, I don't know. Doesn't look right to me. Let's see here. Can I get this? See if we can separate these contacts. That's some gnarly looking contacts there. So hopefully you learned a little bit about how some of these home heating systems work in terms of the baseboard electric heat, both with the thermostats and the relays. Point of doing these videos is so that we can all learn something. So I actually learned how these go together at the same time. So we all get to go on this learning journey together. Hit that like and subscribe button just to help support my channel. It's free. And until the next video, see you later.